Hello everyone. Welcome to the solution of LeetCode problem 213 named House Robber True. In this problem, suppose you are a professional thief or a robber and you want to rob the money from the houses. But here the condition is the houses are arranged in a circle. But one of the condition is you cannot rob the adjacent houses. That means if you rob the first house, you cannot rob the second house because second house is adjacent to the first house. If you do that, it will automatically contact the police if two adjacent houses were broke into the same night. Okay, now the input are given in a array format and each of the array element can be considered at the amount of money stored in this house. So you have to determine what amount of maximum money you can rob in a night. Before starting the discussion of this problem, I assume that you all have understood the house robber 1 problem, because in this solution, I am not explaining the entire house robber theory or the entire dynamic programming solution. I assume that you already understood the basic house robber problem. If you did not understand the basic house robber problem or the house robber first problem, I will give link to the description. First, go and watch the video, understand the house robber problem carefully. After that, come back to this problem and it will be more convenient for you to understand this house robber 2 problem after clearing the concept of house robber 1 problem. Now, I hope you understood the house robber 1 problem. Now here, similarly to the house robber 1 problem, here the input consists of the array. Here in the first example, the input consists of 3 elements of this array. All of them are arranged in a circular fashion. So here, if I rob the second element 3, then the total output will be 3. Now here, in the second input, the given array consists of 4 elements, which is 1, 2, 3, and 1. And here, if I rob the first and third element, the total summation will be 1 plus 3, which is 4. And finally, in the third example, it is given 3 elements in the input array, 1, 2, and 3. And here, if we rob the third element, 3, then the total summation will be 3. I hope you understood the example. Now let's move on to the constraint here. The array length can be in between 1 to 100, and each of the array element can be in between 0 to 1000. I hope you understood the problem. Now let's analyze the algorithm of this problem. Now, similar to the first problem of house robber 1, this problem will also can be solved using dynamic programming. But in the first problem, house robber 1, we are given a single array, but instead the single array in this problem, the array are given in a circular manner. That means the first element of the array is connected to the last element of the array. Here, now we have taken the first example. Here, our first element is 1, our second element is 2, our third element is 3, and our fourth element is 1. These are arranged in a circular manner. Now, what will be the strategy? Suppose at first we robbed into this house and collected the amount of 1 money. As we robbed this house, we cannot rob this house and this house. So again, we rob in this house where the amount of money is 3. So we can say that the total amount of money after robbing is equal to 1 plus 3, which is 4. Now, as we solve this problem by using dynamic programming, according to the first problem of house robber, the equation is strictly similar, where dp of I is equal to maximum of a of I plus dp of I minus 2 and dp of I minus 1, where the dp of 0 is equal to dp of 0, dp of 1 is equal to maximum of dp of 1 and dp of 0. Now, the main part of this problem is that we have to call the dynamic programming function 2 times. At first, we will call the dynamic programming function in this subarray. After that, we will call the dynamic programming function in this subarray. And suppose first subarray will give us the value of x, and second subarray will give us the value of y. So the final output is maximum of x and y. This is the principal algorithm of this problem, where the answer will be the maximum of the subarray which does not contain the last element and the subarray which does not contain the first element. I hope you understood the algorithm after watching the first video. Now let's move on to the code. Now the code is pretty simple. At first we are given a function rob, and the parameter of this function is the input vector. At first we have to check whether our current input vector size is 0 or not. If it is, then we have to return 0. After that, we have to check whether our current input size is 1 or not. If it is, then we have to return only the single element presented in this array. After that, if our current input size is 2, that means we have to return the maximum of the given 2 element. Otherwise, we have to temporarily store 2 vector. The first vector will contain the value from 0 to n minus 1, and the second vector will contain the value from 1 to n, where the first vector will not contain the value of the last element, and the second vector will not contain the value of first element. And the answer will be maximum of these two subarray. And we have to pass these two subarray into a robber method or into a DP method. And inside this DP method, we have to declare a dynamic programming array. The first element of this dynamic programming array is a of 0. The second element of the dynamic programming array is maximum of a of 0 and a of 1. After that, we have to run a for loop from 2 to n. And in each iteration, the dp of I will be the maximum of dp of I minus 1, comma, and dp of I minus 2 plus a of I. After that, we have to return the last element of this dynamic programming function. And if we call this method by using the two subarray, then we have to return the maximum of these two result. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. Now the time complexity of this program is big O of n, because we have to iterate the entire array at least 1 times. And the space complexity of this program is also big O of n, because we have to declare our dynamic programming array. In the worst case, the dynamic programming array will contains all the value, or the size of the dynamic programming array can be equal to the size of the input array. So we can say that in the worst case, that space complexity is big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.